Hello dear student, so let's understand a very basic topic of optical isomerism, that is chiral center. See this question, it was asked in JEE 2020. Total number of compounds with chiral carbon atom from the following question. Then look at this question, JEE 2024 it was asked. The total number of compound with chiral carbon atom from the following are. Okay. So dear friends, to solve such kind of questions, we have to first understand what is chiral center, how to identify chiral center, okay, and we have to practice a lot of questions so that we will have proper hand in this particular concept and we will be able to solve any type of question if it is asked in the examination. So let's get started. So what is chiral center? An sp3 carbon atom bearing 4 different groups is called as the chiral center. It is represented by C star. Later you will study that it always produces an enantiomer upon the exchange. Okay, we will see this later. Forget about the definition. Let's look at here. Chiral center, first of all, it is also called as the stereo center. It is also called as stereogenic center, or it is also called as asymmetric center. Okay, so don't get confused. Chiral center, stereogenic center, and asymmetric center. An atom to be called as a chiral atom, it should have two important things. Number one, it should be sp3 hybridized. Remember my words, it should be sp3 hybridized. And second thing, there should be 4 different valencies or 4 different groups or 4 different atoms should be attached to it. Okay, so these two important things you have to remember. See here, this is a central atom. It may be carbon, it may be nitrogen, it may be oxygen, it may be phosphorus, it may be sulfur. Okay, so don't get confused like chiral carbon is only the chiral center. Chiral center may be nitrogen, it may be sulfur, it may be phosphorus, it may be oxygen. Okay, so this is very important. So this is suppose the central atom, and it is, as you can see, there are 4 single bond, that means hybridization is sp3. So here is white part, here is the yellow part, here is the orange part, and here is the green part, means that showing there are 4 different groups or atoms are attached to it. So this particular atom is first sp3 hybridized, plus it has 4 different valencies attached. That means we can call this as the chiral center. Got it? I hope it is very clear to you. Now let's look at the first question. This is the central atom which is sp3 hybridized, and there are 4 different groups are attached to it: methyl, hydrogen, bromine, and chlorine. That means we can say this carbon is called as the chiral atom, okay, or chiral carbon. Next, look at the second question. This is the carbon central atom. Okay, now it is sp3 hybridized. I hope you know how to find out the hybridization. Then there are 4 different groups are attached to it. Look at the 4 different groups. So this carbon is called as the chiral carbon. Okay, now next, this is again the sp3 hybridized. First requirement is satisfied. Then look at the 4 different valencies. 1, 2, 3, 4. All valencies are different, so this carbon is called as the chiral carbon. Now look at this question. Central carbon atom is again sp3 here. 4 different valencies are attached to it. Look at here. You have to check each and everything individually, and then as we can see, now we can call this atom as the chiral atom. Okay, I hope it is very clear to you. As just we have discussed, chiral center can be carbon, it can be nitrogen, sulfur, phosphorus, or oxygen. So if it is a carbon, there must be ABCD. That means different groups are attached to it. If it is nitrogen, it should have 4 bonds. Okay, so 1, 2, 3, and 4. Okay, if it is phosphorus, 1 is the lone pair, then 3 groups should be attached. If it is oxygen, 3 groups plus 1 lone pair. Clear? So these are different systems in which you have to check whether the atom is chiral or not. The attaching valencies are isotopes, then you will consider them as a different groups. Okay, so this is very important. Now let's solve some questions. Identify number of chiral centers. Okay, so this is the first question. Look at the central atom. This is the carbon. Yeah, it is the sp3 hybridized. First condition is satisfied. Then look at the 4 different groups: iodine, fluorine. So all the groups are the different one. So this carbon is called as the chiral carbon. Okay, now let's look at the second question. Yeah, it is sp3 hybridized central atom. Okay, now look, ethyl, OH, methyl and methyl. Wrong. Here two groups are same, means all four groups are not different, so we cannot say this particular carbon as a chiral. It is not chiral. Okay, now look at the question number 3. This is the central atom, which is sp3 hybridized. This is the first part, this is the second part, this whole group is the third part, and this is ethyl is the fourth part. So all four groups are different one, so we can call this particular carbon as the chiral atom. And as if you have studied optical isomerism, you know that if the compound contains only one chiral atom, it must be optically active 100%. Okay, now look at question number 4. Here is one carbon and here is one carbon. So this carbon is double bond, that is sp2 hybridized. This is also sp2 hybridized, and our first condition was carbon atom should be, or the central atom should be, sp3 hybridized. Okay, and second was that it should have 4 different valencies. So here our first condition does not meet here. Okay, so we will see it contains 0 chiral center. Okay, sp2 carbon has only 3 valencies, so it won't be chiral. So you have to always remember whether the carbon is sp2 or sp, it will never be chiral atom. So for the chiral atom it should be sp3 hybridized. Go next. Now solve the next question. Look at the question number 5. Look at this carbon and this carbon. Now both the carbon are sp3 hybridized. Yeah, but here look at the 4 different valencies, methyl and methyl. So this is CH3 and this is CH3. So this particular carbon is not chiral carbon. But if you look at this particular carbon, it has this one group, this is the second part, this methyl group and this hydrogen. So this particular carbon is called as the chiral atom. So it has one chiral center. Got it? Now look at question number 6. If this is the carbon, look at 4 different groups, hydrogen, tritium, alkyl group and deuterium. So here tritium, hydrogen and deuterium, these are the isotopes. And as I told you, you have to consider isotopes as the 4 different groups. So isotope will act as a different group. So this particular carbon, that is the sp3 carbon atom, is called as the chiral carbon atom. So one chiral center will be present here. Next, look at here. This is sp3 atom, this is sp, and this is sp hybridization. So this will never be a chiral atom because hybridization is sp. This is never be a chiral atom, but this is sp3. So let's check. This is sp3, but this particular carbon has one part is this, one part is this, this and this. So all 4 valencies of this carbon are not different. So we will not consider this as a chiral atom. So chiral atom in this question are the 0 chiral atoms. Okay. So in this way, systematically, slowly, you have to solve, you have to check each and individual center, and then you have to find out whether it is chiral or not. Okay. And a lot of questions are being asked in the JEE Mains in different atoms, even in the 2025 as well. Now let's solve question number 8. This is the nitrogen, deuterium, hydrogen, methyl and ethyl. So yes, this is the sp3 hybridization, and this condition I told you already. Look at this condition. If N is plus, you have to check 4 different groups, so it can be a chiral atom. Okay. So now look at here. There are 4 different groups. So this nitrogen atom is a chiral center. So one chiral center will be present in this particular molecule. Clear? Now look at question number 9. This sulfur is the sp3 hybridized. This carbon is also sp3 hybridized, but it has 2 hydrogens. That means all different groups are not different. So we will not consider this. But look at the hydrogen, is it sp3 hybridized? Now check the part 1, 2, 3 and 4. But these 2 valencies, oxygen, oxygen, are same. So this sulfur being sp3, it will not be a chiral center. So number of chiral center in this compound will be 0. Okay. Now look at this particular question. Same molecule. Just what we have did, we have added this oxygen S16 and this oxygen labeled as the oxygen 18, means these are the isotopes, and you know that we will consider isotopes as a different group. Okay, so the sulfur, number one condition, it is the sp3 hybridized. Yes, now check the four different groups, 1, 2, 3 and 4. Now oxygen 16 and oxygen 18 will be a different groups, so this sulfur is called as the chiral center. So number of chiral center in this molecule will be 1. So this is very important question. Clear? Now next, please solve some cyclic questions out here. If you look into this question carefully, you will see hybridization of every single atom is sp3 hybridized, but this carbon, this carbon, this carbon, this carbon, this carbon, this carbon, this position, you know, all this position which I just marked have at least 2 hydrogen. That means if this is sp3, but if they have 2 same valencies, that means it will never be a chiral atom. Got it? So this carbon having, you know, 2 same groups or atoms. Look at here, CH3, this is CH3, this is CH2, this is CH2. So this will never be a chiral atom. Got it? Okay, now 2 important points are here. One is this and one is this. We have to check now that particular point. Okay, look at here. I will draw this question again. Okay, now this is sp3. Okay, now this is the first part. This carbon have 1 hydrogen, so this is second part. Now we have to check the third and the fourth group. So if you go here, here will be CH2. If you go here, here will be CH2. Now if both are the same, then go ahead, check again CH2, go ahead, here is again CH2, again this they are the same, then go ahead, this is CH, again both sides they are the same, means that if you look at this carbon carefully, it is sp3 hybridized. That means first condition is satisfied. It has 1 hydrogen, 1 ethyl group, 2 different groups, but the third valency and the fourth valency are same, CH2 CH2. Then we move ahead to check if there is any difference. Then again it comes as the CH2 and CH2, no difference. Again go ahead, and here from both the side you will see again the same group. That means, it simply means that this carbon has third and fourth valencies exactly the same. So now you will tell me, will we consider it as a chiral center or not? Yes, absolutely. We will not consider this as the chiral center. It is not a chiral center. Got it? I hope now it is clear to you. Same if you look at this particular carbon atom, again it has 2 different groups. Yes, it is sp3 hybridized as well, but the third and fourth valencies are exactly same. Okay, so it has A, B, but C and D are same. So it will not have A different than B, B different than C, and C different than D. So it will also be not called as the chiral center. So number of chiral center finally in this question will be 0. Okay, so I told you how to check chiral center in the cyclic system. So that is very important. Now you will solve this particular question. Take time and please solve this particular question. Okay, now if you have solved, then please check your answer. First of all, find out the hybridization. So this is a CH3. CH3 means this is sp3 hybridized, but it has 3 different groups like hydrogen, they are the same. So it will never be a chiral center. Got it? That means this is not a chiral center, this is not a chiral center. Again check C, H, 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 this is H, 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 H. Okay, so it has 2 different groups, same. it has two same valencies, so this carbon will not be a chiral, not be a chiral, not be a chiral. Now look at this two carbon, this and this hybridization is sp2, this is double bond sp2, means they are also not a chiral atom. Now remember, only one carbon is left, that is this. Okay, so look at here now. Okay, so now I told you how to find out systematically, like you have to remove sp2 hybridized carbon, sp hybridized carbon. You have to remove the carbon having the 2 hydrogen, 3 hydrogen, that means the same groups or same atoms. So remove that so that your structure will get smooth, like you will have the more clarity to identify the chiral center. Now look at this particular carbon, it has 1 hydrogen, don't forget that. So this is the first valency, this is methyl, that is CH3. This is the second valency. Now look at the third, go here CH2, if you go here CH2, on the both side it will be same, then move ahead to find out the difference. So here this is CH2, but here there will be only CH, and this carbon this is sp3 carbon, and here this is sp2 carbon. That means this particular site, if you go here, this point and this point, they are not same. That means if you zoom out this particular position, it will be carbon, hydrogen, CH3, this is CH2, and here this is CH2 single bond, and this is CH double bond. Clear? Or we will see this as the sp3 carbon, or this as the sp2 carbon. So look at carefully, this part, this part, this part, and this part. That means this carbon is first of all sp3 hybridized, okay, and it has 4 different valencies. So this particular carbon is called as the chiral carbon. I hope this is very clear to you. Okay, in this way you have to solve complex question. You have to eliminate sp2 hybridized all atom, sp hybridized all atom you have to eliminate, then you have to eliminate the carbon having 2 or more than 2 hydrogens. Okay, eliminate all those things, and then you have to check the rest of the things. Okay, like such complex thing, if the 2 valencies are same, then move ahead, then again check the difference, then if they are again same, then move ahead, check the difference. If you get the difference, then there will be they will be called as the 2 different groups or atoms. Okay, I hope now it is very clear to you. One chiral center, and that will be this particular chiral center. Okay, please solve this question. 1 2 3 4, yeah, it will be a chiral center. Okay, now look at here, carefully see, each and every carbon atom is sp2 hybridized. Look at here, sp2, 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 sp2. So chiral atom will be 0. Okay, now look at this very important question. Yeah, so as we know that lone pair will be in conjugation with this double bond group, so here there will be resonance, and the resonating structure will be like this. See, got it? So hybridization of this nitrogen is actually sp2 and not sp3. Clear? So you have to check every time whether the lone pair of the nitrogen is in conjugation or not. If that is in conjugation, the hybridization of the nitrogen is sp2 and not sp3, and that is very important. And we know that if any atom having the sp2 or sp hybridization, it will never be a chiral center. So number of chiral center in this molecule will be 0. So this is very important question. Okay, so if the lone pair of the nitrogen is involved in the resonance, then it will not count as the chiral center. Okay, now look at this particular question, how to solve this. CH3, though this carbon is sp3, it has 3 hydrogen, that means all 4 groups will not be same, so remove that, eliminate this particular part, this will eliminate it. Now oxygen, now this is again sp3, but the 2 lone pairs are the same atom. Lone pair is considered as an atom, but there are 2 lone pair, that means 2 groups are the same, so eliminate this oxygen. Okay, now look at this carbon, this is having 2 hydrogens, so eliminate this. Correct? So only one thing is remain, this particular position. Okay, now look at here very carefully, 1 hydrogen will be there. So this is the first part, this is the second part. Clear? Now look at the third part, if you go from here to here, here is the oxygen, but if you go from here to here, here will be CH2. That means this particular part is a chiral center. So number of chiral center in this question will be 1 chiral center. Clear? What we just discussed? 1, this is the second part. If you go here, here is the oxygen. If you go here, here is the CH2. That means this is the chiral center. Clear? So cyclic molecules you have to look in this particular way. Here, if you solve in the similar manner, you will get 2 chiral center here. Now you have to practice that. Okay. Now here, look at here. This particular carbon, this is CH3. 3 hydrogen, eliminate. CH2, eliminate. CH3, eliminate. Clear? So this elimination is very important, so that you will be able to solve this particular questions quickly. Now look at this particular carbon. It will have 1 hydrogen here. So 1 hydrogen, 1 oxygen, H. This is the CH3 methyl and this is the ethyl. So this will be a chiral center. Now look at here carefully. This is ethyl. This part is the ethyl. This is the OH and 4 hydrogen. So ethyl and ethyl, 2 groups are same. So here there will be no chiral center. Answer will be 0 chiral center. Okay. Now I am going slightly faster. Okay, so that you will be able to solve the questions. Now I will be moving very fast here. Okay, because these are the simple question and you will be able to solve those questions. Now look at these types of questions. If they ask in this fashion, so how to solve this? Look at here. This is CH2, 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 CH2. So this 4 carbon CH2, this 4 carbon CH2. CH2 means 2 groups are same or 2 atoms are same, so this will never be a chiral atom. Okay, so eliminate this, all 4 and all 4, eliminate immediately. Now what is remained? This and this part. Got it? Okay. Now look at this particular position. This is the carbon which is directly attached to 2 carbon, 1 and 2. So this is called as the secondary carbon. Okay, the carbon which is directly attached to 2 carbon is called as the secondary. The carbon which is directly attached to 1 carbon is called as the primary. The carbon which is attached to the 3 carbon is called as the tertiary, and the carbon which is directly attached to the 4 different carbon is called as the quaternary. Clear? So this is secondary, this is secondary, this is secondary, this is secondary, 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 this also secondary, this also secondary. Okay, but if you look at this particular position, this carbon is attached to 3 different carbon, so this carbon is the tertiary. So this is tertiary. Okay, and this particular carbon is also tertiary. Clear? Okay, now look at here carefully. No chiral, no chiral, no chiral, no chiral, as we know. Now this 2 position, look at very carefully. If I select this, now check the 4 different groups. Here is the hydrogen, here is the tertiary carbon. Okay, so 2 different groups are there. But if you move here, here is the secondary, here is the secondary, same on the both side. Go ahead, secondary carbon, that is CH2, CH2, again CH2, again secondary, that is CH2, again CH2 secondary, again CH2 secondary, then tertiary, means that it has this part, 3rd and 4th valency are the same, so it will never be a chiral center, same as for this particular carbon. So number of chiral center in this particular molecule will be 0 chiral center. Clear? Now please look properly in this question. So here will be hydrogen. Okay, this is the secondary carbon, secondary, 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 but this is tertiary, tertiary, and this is tertiary. Okay, now please check it, what is secondary, tertiary, right? Okay, that is very basic part. Now we have to check at these 3 positions. Look carefully. Okay, because this is CH2, 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 so they have 2 hydrogen, so 2 atoms are common, so remove that. Okay, now look at this particular position. This, it has this CH3 part, hydrogen, on the other hand tertiary, and on the other hand secondary. That means this will look like this. So it has 4 different groups here. Okay, so this particular valency is called as the chiral valency or the chiral atom. So this carbon is the chiral center. Got it? Okay. So one chiral center we got, and that is this. This is the chiral center. Clear? Okay. Now look at this particular center. One, this has hydrogen. Here it has secondary part. Here it has tertiary. Here it has tertiary. Clear? Okay. Now one hydrogen, one secondary. Now look at the tertiary valency. What is there in the tertiary? Here is the carbon, hydrogen, and attached to it at the secondary. This position has carbon, CH3, hydrogen, and attached to is a secondary. Okay, so look at this whole group and whole group. This is same or different? Yes, it is different, because this carbon is attached to one hydrogen, one secondary carbon, and one methyl group, but this is attached to one hydrogen and secondary carbon and secondary carbon. Got it? So this carbon is again chiral atom. So this is also a chiral atom, and in the similar way this is also a chiral atom. So number of chiral atoms will be 3. I hope this is very clear to you. This is an important question. Okay, now please solve these particular questions. We have already discussed how to solve them. We will move ahead. Now again, these are easy question. Just remember, nitrogen lone pair is in, there is resonance, so the hybridization is sp2. Here also nitrogen will be in resonance, so hybridization will be sp2. So you will not consider nitrogen in the calculation of the chiral center. Okay, now a very important question. Examiner will ask you, find out the number of chiral center in the glucose or the fructose, and these are given in your chapter called as the biomolecules. So they can ask this question. Clear? And this is also important for to identify the enantiomer and diastomer. So you have to check all the points clearly. Okay, now look at here. Number 1, this CHO is actually like this, C double bond OH, aldehyde. So this carbon is the sp2 hybridized. So this is sp2 hybridized. So you will not check this for the chiral center. Okay, eliminated. Now look at this carbon. It has hydrogen, OH. So it has 2 same group, so cannot be chiral. So this is also eliminated. Got it? Now look at this particular position. It has one side hydrogen, one side oxygen, one side C double bond OH aldehyde group, and fourth side all these groups. So now can you see 4 different groups? One hydrogen, one OH, one this group, and one all this group. So all 4 groups are different. It is sp3 hybridized as well. So this particular position is called as the chiral position or chiral atom. Okay, now look at this particular carbon. One OH, one H, one this particular part, and one this particular part. So here you can see aldehyde functional group. This is CH2OH. So these 2 groups are different. HOH are different. So all 4 parts are different. That means this is also called as the chiral center. Got it? Now look at here at this center. OH, H, this particular part and this particular part. All 4 groups are different. So again this is chiral center. Now look at this particular center. 1, 2, 3, 4. 4 groups are different. Now this is also called as the chiral center. Got it? I hope it is very clear to you. So number of chiral center in the glucose, if anyone asks you, answer will be yes. Answer will be 4. Clear? I hope now it is very clear to you. Now you can easily identify same for the fructose. See this CH2, that is carbon is having 2 hydrogen, 1 OH, so it will never be a chiral. sp2 hybridized, this carbon will never be a chiral. Again this is having 2 hydrogen, so never be a chiral. So you have to only check 3 position, 1 2 3. So these 3 are eliminated. I'm telling you, first try to eliminate the position, so the molecule will be simplified for you. Okay, now look at these 3 positions, 1 2 3. Okay, number 1 position, hydrogen, OH, this third part, and this is the fourth part. So this is a chiral center because all 4 valency are different. Okay, now look at the second part. This is sp3 hybridized. Yeah, one part OH, then H. This is the third part and this is the fourth part. All 4 groups are different one. So this is again a chiral center. Next, OH, H, this part and this part, all 4 are different. Then this is again a chiral center. I hope now this is very clear to you. So number of chiral centers in the glucose are 4, but in the fructose there are 2 chiral centers, 3 chiral centers, sorry. Okay. Now we have solved plenty of questions. Now please pause the video and solve all these 6 questions out here. Okay, I will directly tell you the answer. This will have the 0 chiral center. It will have 1 chiral center. It will again have 0 chiral center. It will have 0 chiral center. It will have 1 chiral center, and this is lactic acid. It will have 1 chiral center. Got it? So these are very simple questions now for you, and I hope you will be easily going to solve these questions. Okay, now let's solve this question, cholesterol. First of all, what I told you, try to eliminate the things. So start from here. This is CH3, not a chiral. CH3, not a chiral. Okay, now look at this particular valency. This is carbon. Okay, it has CH3 and CH3, means 2 groups are the same. Eliminate this particular part again. Okay, so we have eliminated 1 2 and 3 carbons. Now look at this and this position. They are CH2 CH2 CH2, means they have 2 hydrogens, so it will never be a chiral. So again we have eliminated 1 2 3 4 5 6. So all these 6 positions are the eliminated. Remove it. Then look at this position. This carbon has the CH3. Here is the H. Here is one part and here is the whole part. So now you can clearly see this has sp3 hybridization plus 4 different parts. So this will be your chiral carbon or chiral atom. Got it? Okay. Now look at this particular carbon. Here this will not be a chiral. Look at this particular carbon. One is the H, one is this whole part, second is the H, and third, this particular carbon is the tertiary carbon. This is the secondary carbon. So if you look at this position, it has one this part, one hydrogen, one side secondary carbon, one side tertiary carbon. That means it has 4 different groups. Clear? So you will say this is also a chiral atom. Got it? Now I hope it is getting easier to you to understand. Okay, now look at this. This is CH2, eliminate, CH2, eliminate. Again this is CH2, eliminate, CH2, eliminate. Clear? Now look at this particular position and this particular position. Okay, so this will have hydrogen. Here is the tertiary carbon, here is the secondary carbon, here is the tertiary carbon. Okay, so here hydrogen plus secondary, 2 different things. Here is a tertiary, but here is also tertiary. But now if you look at this particular carbon, it has CH, this whole group, okay, and the attachment is here. But here the carbon is having CH2 and this. So this whole group and this tertiary group are different. So this is also a chiral and this is also a chiral. Okay, so I'm marking this as a chiral and this as a chiral atom here. Okay, now look at here. This carbon H, here is the different thing, here is the different thing, and here is the different thing. So this is again a chiral atom. Again check this particular carbon, hydrogen, different part, different connection. So this is again a chiral atom. Got it? Okay, now this is sp2 sp2, never be a chiral. This is never be a chiral. Remove. Okay, remove. So check this position and this position now. Okay, if you check this position, it has one hydrogen, one side CH, that is sp2 carbon, one side this whole group, and on the other side this part. So all four parts are the different one. So this carbon is a chiral center here. Clear? Okay, same way this is also a chiral center. I hope you understood this particular question. So number of chiral center in this particular molecule will be 8 chiral center. Clear? So in such complex question, try to eliminate the things. Okay, then after elimination, check the things, check whether the carbon is attached to secondary carbon or tertiary carbon. If they are attached to the secondary or secondary, both side, then check that those secondary are attached to the same valency or the different valencies. If there is any single difference, if any single minute difference, then you will consider both the parts as a different part. Okay, and there will be chances of that particular carbon to be called as the chiral atom. Okay, now in the similar way, eliminate this CH2, CH2, CH2. Now you remain only with the two centers, 1 and 2. Now look at here. Here is one hydrogen, one methyl. Here there is a CH2. Here if you come, there is a CH2, again CH2, but here CH3. So this particular part, hydrogen and methyl are 4 different groups. So you will call this particular carbon as a chiral atom. Okay, in the similar way, this is also a chiral. Now you have to practice for it. Clear? Now try to solve this particular question. 1 2 3 4 5 6 7 question. Try to find out and write your answer in the comment section. If you have any doubt, just put a question in the comment section, I will answer. Okay, now it is very easy for you to understand and solve this such type of question. Okay, now solve a structure of camphor. You know, these both representation are the same. Okay, so first of all, eliminate the things out here. This is sp2 carbon, eliminate this. This is CH2, eliminated. This is CH2, eliminated. This is CH2, eliminated. Okay, now this is the carbon attached to two same groups, CH3, CH3, eliminated. CH3 eliminated. This is also eliminated. So what is remained there? This particular part and this particular part. Okay, if you see carefully in this representation, where is their location? This is their location. Got it? Now look at here. Here it is attached to one hydrogen, it is also attached to one hydrogen. So hydrogen on this side, this is attached to CH3, CH3. On this side, it is attached to CH2, CH2 same. So go ahead, this is CH2, but here that is C double bond O. That means if you focus only on this carbon, it is attached to hydrogen. On this side, this is attached to CH2 C double bond O. On this side, it is attached to CH2 CH2. So 1, 2, 3, and on this side, it is attached to CH3 CH3. So if you look carefully at this particular position, it is attached to one hydrogen, CH2 CH2 on this side, and on this side CH2 C double bond O, and on this side CH3 CH3. So this carbon is definitely be a chiral center. Okay, on the similar manner, the bottom carbon is also a chiral center. Clear? I hope now it is very clear to you. So number of chiral center in the camphor will be 2. So in such complex question also, with stepwise, with a systematic manner, you will be able to solve a very difficult question as well. Now let's solve this particular question. Now student get confused how to solve such questions, but again with the steps that what we have discussed, you will be easily able to solve this particular question. Okay, look at here. First eliminate the things. CH2 eliminated, CH2 eliminated, CH2 eliminated, CH2 eliminated, CH2 eliminated. So now what we have to check here? Okay, this position, this position, this position, and this position. Here there is no carbon. Okay, no carbon is present. This is representing a bond. There is not a carbon atom present. Okay, now look at here. 1, 2, 3 and 4th position. This is tertiary carbon because this carbon is attached to 1 carbon, 2 carbon and 3 carbon. Clear? This is also tertiary, tertiary, tertiary. But this carbon is secondary. Check. Attached only to 2 carbon atom. So this is secondary, 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 secondary and secondary. Now look at here. This particular carbon is having 1 hydrogen. On one side it has tertiary carbon attached. So if I put it here, this is 1 hydrogen. I am drawing this particular part. Okay, on this side it has secondary carbon, secondary carbon. Okay, on this side tertiary carbon. On this side this is attached to secondary and tertiary. So this is secondary and attached to tertiary. On this side this is secondary and tertiary. Now if you look closely, first part is the hydrogen, second direct attachment to the tertiary, here secondary, secondary and secondary, tertiary. Can you see 4 different arrangement here? Yeah, my dear student, this carbon is a sp3 hybridized, as well as it has 4 different arrangement, or the group of atoms are attached. So this carbon is called as the chiral center. So in this way, this molecule, if you check properly one by one, it will have 4 different chiral centers. And I hope now it is very easy for you to understand the things. Okay, now take a pause and try to solve this particular question. I will just tell you the answer. 0 chiral center, 0 chiral center, 0 chiral center. Here there will be 2 chiral centers. Okay, again try to solve this question. Here there will be 2 chiral center. Same question, these are just different representation. Here there is also again a 2 chiral center. So you have to pause the video and try to solve the questions by your own. Okay, now let's solve this particular part and this particular part. Okay, so this is CH3 eliminated. Okay, this is CH3 eliminated. Now we have only this particular carbons. Look, this is sulfur, this is sp3 hybridized. Clear? One is the oxygen, one is lone pair, one is this part and one is this part. So this is definitely a chiral center. Now look at here, it has one CH3, one H, one is this part and one is this part. That means it is also a chiral center. Now look at this particular carbon. One is CH3, one side this is H, one side this and this. All 4 parts are different. So this is again a chiral center. Now here one H, one Cl, one is CH3 and one this part. So this is also a chiral center. So 4 chiral center will be there. Okay, clear? Now try to solve this particular question properly. It has 4 different chiral centers. If you have any doubt, please comment in the video, comment below the video. Okay, now this is called as the adamantine system. Clear? In the calculation of stereoisomerism, I will tell you why this system is very important. Because in this system, if you calculate, I will tell you how to calculate. Number of chiral center will be 4. But when you calculate the stereoisomers, then you have to consider the number of chiral center as the 1, because they are the dependable system. Clear? So we will see that in later part, but for now you have to just calculate the number of chiral centers. So look at here. First of all, eliminate this particular part. Eliminated. So only 4 parts remained. First, second carbon, third and fourth. These are of our interest. Now look at here. This carbon has 1 chlorine. If you go this side, CH2, CH2, CH2. All 3 sides are the same. Then move ahead. This is carbon fluorine. This is carbon iodine. This is carbon bromine. That means this carbon have 1 chlorine. Here carbon fluorine. Here carbon iodine. And here carbon bromine. That means all four parts are different. Clear? So clearly this is called as the chiral center. Okay, so I will call this particular part as the chiral center. If you do the same for all four marked atom, then you will get to know that these all four are exactly different chiral centers, that is they are the chiral atoms. So here in this way, just now what we did for this particular position, do it for this three. The number of chiral center will be 4 chiral centers. Okay, now just try to solve this particular question. Eliminate these three positions as they are CH2. Interested in these three positions only now we are. Okay, this and this. Let's check the first position. This is sp3 hybridized. Okay, first part, second part different, third part, look at here, this is CH2 attached to CH3. Okay, here CH2 attached to CCl. So definitely this particular part, this part, lone pair, and this all four groups are the different one. So this sulfur is called as the chiral center. Got it? This is the carbon, hydrogen, chlorine. From this side sulfur, from this side CCH3. So 1, 2, 3, 4 all groups are different. So this is also a chiral center. Again carbon, hydrogen, 1, 2, go here, sulfur, go here, chlorine. So all four groups are the different one. So this is again a chiral center. So number of chiral center, 3 chiral center in this particular molecule. Now I hope it is like slightly easier for you to understand the things. Okay, now here some complex molecules are there, vitamin D3 and these cyclic molecules. Now you have to go exactly that how we did for the complex system, for the cyclic system, you have to practice it. Okay, now dear student, just we are going to revise a simple concept of nitrogen, that is called as the amine flipping or amine inversion. But trust me, this is the most important part. Because of this, you may lose your marks. Okay, so what is nitrogen or amine flipping? Look at here. Here there is nitrogen, 3 different groups are attached here. He is the lone pair. Okay, hybridization is sp3. At room temperature, it will consume hardly take 6 to 8 kilocalorie of per mole of energy, right? Very less energy is required, and because of this, this three atom will go in this direction and the lone pair will go in this direction. Okay, so this is called as the flipping. Like here you can see A, B, C, 3 groups. They will, lone pair come down and this 3 will go up. So this is called as the flipping. So this will convert into this will convert into this, and this is very random conversion, very fast conversion is there. Okay, so in this conversion, when these 3 atoms go up and lone pair comes down, so look at here, a transition state is formed whose hybridization is sp2 hybridized, correct? And again there is a sp3 hybridized product is formed. So the transition sp2 is very, very important. So nitrogen flipping is the ability of sp3 nitrogen to turn itself inside out like an umbrella in the rain, converting one pyramidal form into its mirror image. Okay, now I am not going to explain in much detail here because this is the GOC concept, but here I will going to discuss about the questions on the chiral center on this particular concept. Okay, so what is most important conclusion here? Look at here, listen next 2 minutes very carefully. Nitrogen can exist in the form of open chain compound, or it can be present in the form of ring, and it can be present in the form of bridgehead position. Okay, so first, if the nitrogen is a part of open chain compound, then we have primary carbon, primary nitrogen, secondary nitrogen, tertiary nitrogen, and quaternary nitrogen. Look at here, this is the open chain compound. All are the open chain compound. Okay, remember here, primary, secondary, and tertiary, they undergo flipping, and because of this flipping, they will never be chiral. Okay, so whenever you will see primary nitrogen, secondary nitrogen, tertiary nitrogen, so you will not consider or count them as a chiral atom or chiral center. Got it? And the reason is the flipping. Okay, but in the quaternary nitrogen, as lone pair is gone, correct, 4 bonds are there, so the flipping is restricted. Now it will not flip, and if flipping is blocked, right, by removing the lone pair and forming the bond, then this compound quaternary nitrogen can be chiral only if all 4 groups are different. Correct? So if the nitrogen is part of the open chain compound, you will not consider it as a chiral center or stereo center when it is primary, secondary or tertiary. But if it is a quaternary and all 4 groups are different, then you will consider it as a chiral center. Got it? It's a very important. Now if nitrogen is a part of the ring, then let's check ring size maybe 3, 4, 5, 6 and 7 membered. If look at this is a 3-membered ring and nitrogen is a part of ring. Okay, this is the 4-membered ring and nitrogen is a part of ring. This is the 5-membered ring and nitrogen is a part of ring. This is 6-membered ring and nitrogen is a part of ring. This is 7-membered ring and nitrogen is a part of ring. Got it? And now in this situation, what you will do, look at here. When nitrogen is a part of 3-membered ring, 4-membered ring and 5-membered ring, the flipping is blocked here. Flipping is blocked here because the sp2 hybridization transition state cannot be attained because here high strain will be there. Got it? So in the 3, 4 and 5-membered ring, flipping is blocked. That means you can check here chiral center. Okay, so in 3, 4 and 5-membered ring, if 4 different atoms or 4 different groups are present, then you will consider these nitrogens as the chiral center. Got it? But if in case of 6 and 7-membered ring, flipping is present. So flipping is absent in 3, 4, 5-membered ring, but it is present in 6 and 7-membered ring. So in case of 6 and 7-membered ring, got it? You will never consider them as the chiral center. Clear? So what is the conclusion here? Nitrogen can undergo flipping, and if it's present in the open chain compound, then primary, secondary and tertiary nitrogen, they can undergo flipping and therefore they cannot be considered as a chiral center. But if nitrogen is quaternary, then if there are 4 different groups, then you will consider it as a chiral center. But if nitrogen is a part of ring, then you have to check the size of the ring. Then it may be 3-membered, 4-membered, 5, 6 and 7-membered. Then flipping is absent in 3-membered, 4-membered and 5-membered. But flipping is present in 6 and 7. So if in the 6 and 7 flipping is present, then there will be nitrogen will never be a chiral center in 6 and 7. But in 3, 4, 5 flipping is absent. So if all 4 groups are different, then they can be a chiral center. Got it? So let's solve some questions. Identify where nitrogen is chiral or not. So look at here, open chain compound. If this is an open chain compound and this is not a quaternary, so this is chiral center. Nitrogen is not a chiral center. Okay. Now look at here. This is again open chain compound and it is not quaternary. Lone pair is present. It is not a chiral center. Now look at here. This is open chain compound. Lone pair is present. That means it is not quaternary. It is not a chiral center. Then look at here. Nitrogen is a part of ring, but ring is of 6-membered. And if it is 6-membered, flipping is present. And if flipping is present, nitrogen can never be a chiral center. Okay. Now, nitrogen is a part of ring. Size of the ring, 4-membered ring. If size of the ring is a 4-membered ring, then you have to check A, B, C, D. If all 4 groups are different, then nitrogen can be chiral center here because flipping is blocked. So look at here, nitrogen attached to one lone pair, hydrogen. Here, carbon, chlorine, carbon, ethyl. So all 4 groups are different. Nitrogen is a chiral center here. Got it? Now, we are discussing very important information here, right? So be careful. Now, here nitrogen, 3-membered ring, flipping blocked. Flipping block means they can be chiral if all 4 groups are different. So look, hydrogen, lone pair, here chlorine, here bromine. All 4 groups are different. So nitrogen is a chiral center here. Okay. Now, this is the 7-membered ring. Flipping is there. Nitrogen will never be a chiral center. I hope it is very clear to you right now. Now, the last and most important part is that if nitrogen is a bridgehead atom, when nitrogen is present at the junction between 2 or more rings in a bicyclic or polycyclic system, it is called as bridgehead nitrogen. Look at here. This is the first cycle and this is the bridge. So nitrogen is a part of the bridgehead atom connecting the 2 rings. Okay. Here is also, it's a bridgehead nitrogen. Such nitrogen are called as the bridgehead nitrogen or bridgehead atom. Now, you have to remember one thing. In the bridgehead nitrogen atom, you have to remember there is never be a flipping. Okay. It will never flip irrespective of the ring size. So here, if the nitrogen is at the bridgehead position, then you will not check the size of the ring. You will simply say nitrogen will never go for flipping. So you have to check for if there is a 4 different groups are present, then it will be chiral atom. And if there are no 4 different groups are present, then nitrogen will be considered as Yes, it will be considered as not chiral atom. Got it? So look at this example. So this is a bridgehead atom, this is a bridgehead nitrogen. So if they are the bridgehead, then flipping is blocked 100%. Don't check the ring size. Okay, so flipping is blocked. Now only you have to do check the 4 different groups. So here is one is lone pair, one is CH2I, this is methyl methyl, and this is CCl. So 1, 2, 3 and 4, all 4 are different. So this nitrogen is chiral. Got it? Look at here. So this is nitrogen lone pair, this is carbon ethyl, here carbon methyl, and here carbon methyl methyl. Got it? So all 4 groups are different. So this nitrogen is also a chiral atom. I hope now it is very clear to you. Now let's solve the most important question that NT asked in 2020. It's a very important question. First of all, eliminate all sp2, sp, ch2, ch3, all such groups. Okay, so all these benzene sp2 hybridized atoms, eliminate this, remove it. This ch3, eliminate. What we have to focus on this system. So this carbon is attached to hydrogen methyl OH, and 4th group is this. So definitely this carbon is a chiral carbon. Okay, so this is our first chiral atom right now. Okay, next, now check this particular part. Okay, so this is one segment, this is second, this is third, and 4th is the hydrogen. So definitely this particular carbon is a chiral atom. Okay, now look at the oxygen. It has 2 lone pair, so it is not a chiral atom. Got it? Now look at this particular carbon. So here there is one hydrogen, one side there is nitrogen, on one side there is CH2, on one side there is CHO. Got it? So there are again 4 different groups. So this carbon is also a chiral atom. Okay, now look at here. This is CH2, don't look at it. CH2, don't look at it. CH2, don't look at it. CH3, don't look at it. CH2, don't look at it. So this is also CH2, don't look at it. So what we have? Center 1, center 2 and nitrogen. 3 things we have to check now. Okay, we have eliminated all other things. So now check this particular part. It has one hydrogen, one ethyl, one side nitrogen, and one side CH2 CH3. So again it is a chiral atom. Got it? Now look at here. This is hydrogen. Again on one side this group, on other side they have nitrogen, and on other side they have this particular group. So again this particular carbon is again chiral atom. Got it? Now look at this nitrogen. This is the nitrogen atom. Okay, so can you see I have drawn this nitrogen here? Can you see here that this is a bridgehead nitrogen, and in the bridgehead nitrogen, listen, flipping is blocked. If flipping is blocked, then you have to check 4 different groups. If 4 different groups are present, it is chiral. Okay, so now check here 4 different groups are present or not. Here there is CH2, and this is a connection. Here this CH2, CH, and this is the part I drawn this part here. Okay, don't get confused. Now here there is proper whole thing here. This complete thing I called it as G. Okay, I named it as G. Now look at here. Nitrogen, one lone pair, one this part, one G, and one this. So all 4 different groups are present. So this nitrogen is a chiral. Okay. Now the answer that NTA has given is 5, but we get 1, 2, 3, 4, 5, 6. Then does NTA wrong? Yes. So in such cases, my dear friends, total number of chiral atoms are 6. But still, if you don't read question carefully, then your answer may be wrong. The question they ask the number of compound with chiral carbon atom. They only asked carbon atom. So total chiral atoms are 6, but in that 5 are the carbon and 1 is the nitrogen. So our answer as they ask especially for the carbon will be 5. So this is very important question. I hope it is very clear to you right now. Clear? Now this question is asking 2024. Total number of compound with chiral carbon atom. Carbon atom, again chiral carbon atom. Okay. Now I am directly writing the chiral centers here. Now I hope you're capable of finding the chiral centers in simple molecules. Okay. So how many chiral centers are there? 1, 2, 3, 4, 5, 6. So chiral centers are 6. But what they ask us? Number of compound. They ask number of compound with chiral carbon atom. Correct? Total chiral center are 6. But we have to tell the number of compound which contain the chiral center. So this is the first compound. This is the second compound. This is the third compound. This is the fourth compound, and this is the fifth compound. So compounds are 5 because this molecule don't have any chiral center, this molecule don't have any chiral center. So there are 4 compounds they gave, out of which 5 compound have chiral center, 2 compound don't have chiral center, and 5 compound have how many number of chiral center? That is 6 chiral centers. Got it? So the total number of compounds they ask, the answer is 5. But if they ask total number of chiral center, then answer will be 6. So in both questions, if you know the concept, if you know each and everything, still there are the chances that you may pick wrong answer, or you may write wrong answer there. Why? Because if you don't read question properly in that case. Got it? Okay.